Hello guys, welcome back to MedZone African Motives. Still working on our power machines N6, and this is the internal combustion engine concept questions that we're going to focus on. So we just need to understand these typical questions. As I always say, guys, power machines, it's all about the formulas and how to manipulate your formulas. So let us work and see. We are given on question number 5, that is a 4-cylinder. So remember, when you're given, we're working with the cylinders, E represents the cylinders, all right? So there we've got E, which is equivalent to 4, the number of cylinders. Then it's a 2-stroke cycle, all right? So the number of strokes that you're given there is given as 2. So where and how does this part of strokes affect in our calculations? This affects the engine speed, our N. It affects our engine speed, all right? So it follows that from our calculations that we're dealing with N, provided that we have got our speed in revs per second, N is going to be the speed in revs per second over a 2 when we are given a condition of a 4-stroke. All right, our N is going to be the revs per second over 1 when we are given a 2-stroke. That is for the number of strokes. Then we've got a double acting when you multiply by 2. A double acting, you multiply by 2. But for a 4-stroke, revs per second divided by 2, 2-stroke, revs per second over 1. So this here, it affects the speed, N. So if we are to consider this, our N, this N here is going to be affected. Our N is going to be taken as the speed to be in revs per second. We divide by 60 because this is revs per minute. So it's going to be 2,400, which is now in revs. All right. I mean, that is the revs to be per second. We divide by 60 like this. That will be revs per second. But take note, we are saying for a 2-stroke, we are going to be having revs per second over 1. So meaning to say this, we're going to multiply by 1. So that is our N. If it was a 4-stroke, you're going to multiply by 2. But this one is a 2-stroke. So that is when you use N, you're going to use your N like this for a 2-stroke. Then we are given, that's petrol engine, and this is, okay, no problem. The other information that we have, we are given here, the bore size. All right, so what is the bore size? We're talking about the diameter in this case, all right? So this is the diameter, that is our bore size, guys, from our N5, but this is supposed to be in meters. Divide by 1,000, that's 0.08 in meters. Then also you're given the length, the stroke length per cylinder, that is the stroke length, 90 millimeters, that will be 0.09 meters. And also the fuel consumption, that is the mass of fuel. So you're given the mass of fuel, but it's given per hour. So this is the mass of fuel per hour. We are also having the calorific value, given 44,000 kilojoules per kilogram. All right, as I said, whenever you work with the calorific value, it's supposed to be in kilojoules per kilogram. So this is fine as it is. All right. Then also we got the brake mean effective pressure. Take note. We have got what? The brake mean effective. So that is our P brake mean, like that, which is 370 kilonewton per square meter. These units represent what? Pascal, which is kilopascal. So this is 370 kilopascal. The brake mean pressure, effective pressure, the brake mean effective pressure. And we've got the compression ratio, 7:1. Remember, when a given compression ratio like this, it means R is equal to 7/1, where R represents what? The compression ratio, or simply 7/1 is what? It's 7. All right. Then also we've got the efficiency ratio. All right. We are given there the efficiency ratio. Which efficiency ratio are we talking about that we are given in this case? This is the indicated efficiency ratio. All right. So we've got the efficiency ratio of 55%, and the gamma for A is given as what? As 1,4. So this is the gamma for A. All right, so the question was, from this information that we have, 5.1, calculate each of the following. 5.1, the air standard efficiency. All right, I'm just going to utilize this space here, no problem. I think we're going to win here. So from the information that we are given, the air standard efficiency, how can we calculate the air standard efficiency? That is our first question. That is the question 5.1. Okay. If we are to check according to the information that we have, there are so many formulas where the air standard efficiency is being applied or is being used. All right. Like I said, it's an advantage that we've got our formula sheet here. If we check, there are different formula for air standard efficiencies. We've got this formula, we've got this formula, we've got this formula, which is taken from the heat added minus heat rejected over the heat added. But we do not have any heat that we're given there. All right, we are given the compression ratio and also we are given gamma. So why not take this formula? Because we have the compression ratio, we also have the gamma from our information that we are given here. All right, we have the compression ratio. We are given that our gamma here and also the compression ratio is 7. So we can use that formula, which says that the air standard efficiency is given as, that is 1 minus 1 over R, which is the reciprocal of what? The compression ratio to the exponent of gamma minus 1. So in some cases, we might find a condition whereby we are given temperatures. All right, we might find conditions whereby we're given temperatures. On that condition, we use this concept T2 over T1, that is T2 over T1 is equal to R to the exponent of gamma minus 1 in our manipulations. But in this case, we are given direct everything. So we're just going to apply this formula. We've got, like I said here, this is our R, which is 7 over 1 or 7. So to find 1 over R, it means the reciprocal of this. 1 over this that's the reciprocal. So that's 1 over 7. As we are given on our formula, it's 1 over R. So it's the reciprocal of what we are given. 7 over 1, 1 over 7. So that means we're going to have 1. And this, you can also write it as a percentage. So to write it as a percentage, you simply have to multiply everything that you're going to get here by what? By 100%. All right. So that means in this case, we simply have to substitute 1 minus 1 over our R in this case. I mean, we are given 7 or 7 over 1, which gives us a 7. So which is the reciprocal, 1 over a 7. So that's 1 over a 7 to the exponent of the gamma for air. We are given the gamma for air, and this case is what? It's 1,4. So there we have everything. The gamma for air is given as 1,4 minus 1. So this whole part that we are obtaining in this case must be multiplied to 100% for a percentage. If you want a percentage, you just want to leave it as a decimal. You leave it like that, you can have your answer as a decimal. It's one and the same thing. But as a percentage, we are going to obtain something like 54,084345, something like that. So that is to 3 decimal places, going to be like that, all right, percent. So that is what we are going to have for this air standard efficiency that we given to calculate. 3 marks for that. All right. Then we move on. The indicated thermal efficiency. Indicated thermal efficiency. All right. Let me just write it down here so that we can check. That's 5.2. So we need to calculate the indicated thermal efficiency. How are we going to calculate this? All right. We have got the air standard efficiency in this case. All right. Let us go back to our formulas. I want you to check this. There is this formula. Let's hope they listed it down for us here. Or let's hope I inserted that formula. Yes, I think we have it here. All right. They gave us about the indicated efficiency ratio. All right. That it is equivalent to the indicated thermal efficiency over what? the air standard efficiency. So meaning to say, with this information that we have, we can be able to calculate that. Our indicated thermal, because we're supposed to calculate what? The indicated thermal efficiency. That is the one that we are supposed to have. So from our air standard efficiency and the indicated efficiency ratio, because we have this, remember I talked about this. All right, so let us take our formula down. I talked about this from this formula. That is this formula here. Not the formula actually, but from this one, from this efficiency ratio that we're given here. This is our indicated what? Our indicated efficiency ratio. So we are saying the 55% from that. All right, let us take this way. So we are going to calculate this from the indicated thermal efficiency, from indicated thermal efficiency. We saw that this formula for the indicated thermal efficiency is equivalent to them indicated thermal efficiency. All right, that is indicated thermal efficiency, in this case, everything over what? Over the air standard efficiency. So we have got, guys, how am I having two efficiencies? I'm now surprised. This is indicated thermal ratio to the indicated thermal efficiency over the air standard efficiency. Very sorry for that. All right, very sorry for that. This is the ratio. All right. So we're taking from that formula exactly that we had from our formula sheet. All right. So this is the ratio here. So as we need to calculate this indicated thermal efficiency. All right, this is not the only formula. There is also this formula, because you might wonder to say, why are we using this only? There is also this formula for the indicated thermal efficiency. Let's hope it's there. Let's hope it's there here. All right, here, if we check here, there is also this formula here. The indicated thermal efficiency is equivalent to this. But if you check in this on this formula, we do not have the indicated power. All right, we do not have that. We do not have the indicated power. Yes, the mass of fuel per second, we can have it because we've got the mass of fuel per hour. We can have the mass of fuel per second. But the indicated power we do not have. So meaning to say, we need this. The calorific value, we have this. So this was going to limit us on this formula. That's why we say we're not using this formula. We are using this one that we have from what? From the efficiency ratio. From the efficiency ratio, we can be able to use this, all right, from this one of the efficiency. No, it was, okay, there was the previous one, no problem. I think I wrote it down here. From the what? Indicated thermal ratio. So meaning to say our indicated, let us just have it as efficiency ratio properly here. Efficiency ratio. We have that percentage, which is 55%, if you still remember. So you're just going to insert our values. That is 55%, our efficiency ratio, 55%, so that you do not have a confusion. So in order for me to remove the decimal, I'm just going to divide by 100. So it will be 0.55 is equal to the indicated thermal efficiency. The indicated thermal efficiency over our air standard efficiency, which is the one that we calculated here. So it's either going to write it as a decimal or as a percentage. If you want your answer to be as a percentage, you're going to write this as a percentage. So I'm just going to use this as a percentage, 54.084%. So this is same as over 1. So I can be able to calculate the indicated thermal efficiency. All right, so that is our indicated thermal efficiency. In this case, if you multiply by 1, you're going to have the indicated thermal efficiency as the product of these two. All right, that is 0.55 times 54.084%. So since this is already as a percentage, it means we are obtaining our answer direct also as a percentage. And that was going to give us 29.746 to 3 decimal places as a percentage. So that is our indicated thermal efficiency. Right? So is this so that formula for the indicated power was going to work, but it was because we are limited. We do not have, or we are not having the indicated power. All right. Then the other part now, they want us to calculate 5.3. That is the fuel power in kilowatt. In kilowatt, that simply means in kilojoules per watt per second. How do you calculate the fuel power? All right. So in order, remember, also, we need this from our fuel power. Actually, we had this from our science. Exactly. Q, when you're dealing with the fuel, it's supposed to be the mass of fuel. Maybe you're talking about coal, whatever fuel that you're given, times the heat value, which is what? The calorific value. So that is the fuel power. So the fuel power is simply equivalent to the mass of fuel times the calorific value. So why am I writing about the kilojoule per second for the kilowatt? Remember that kilowatt is kilojoule per second. This is important, very, very important, so that you know the units to use for the mass of fuel. The mass of fuel is supposed to be in kilograms per second, so that our answer is supposed to be in kilojoules per second, which represent the kilowatt, while our calorific value is what? Kilojoules per kilogram. So that is the idea there. All right. So meaning to say your fuel power with these units is going to be the mass of fuel. How do we convert what we're given on the mass of fuel? Because we have got this mass of fuel, if you still remember, the fuel consumption, which is the mass of fuel per hour. That is 9.2 kilograms per hour. Per hour. 9.2 kilograms per hour. But as we need kilograms per second, so how are we going to convert this? 1 hour is equivalent to 3,600 seconds from 60 times 60. So if it is 3,600 seconds, it means we are going to divide by 3,600 seconds to convert 1 hour to seconds times the calorific value in kilograms per and kilojoules per kilogram. That is in kilojoules per kilogram. We've got 44,000 that we are given there. So that is going to be 44,000 kilojoules per watt per kg, which is per kilogram. So this is going to give us the fuel power in kilojoules per second. And like I said, that the kilojoules per second represents what? The kilowatts. So that's finding the power, the fuel power in what? In kilowatts. And that was going to give us 112.4444, and so on and so on and so on. So that is what you're going to obtain in kilowatts. All right. So that was our 5.3. Let's check 5.4. The brake power in kilowatt. In kilowatt, the brake power. All right. So it follows that the actual brake power is supposed to be given as, okay, there is this part of 2 pi n, if you still remember that formula, 5.4. So we need the brake power. So there are two formulas that you actually have, but you see that one is going to work and another one is going to be limited. All right, let me just take you to the formula sheet. Okay, don't worry. Just going to be stage by stage. All right, here. We do not have this one. We do not have the brake thermal efficiency. We are given the indicated thermal efficiency. If we had that, we're going to manipulate it to calculate the what? The brake power. All right, let us move on to the formulas that indicate the brake power here. There are two formulas that you're going to see that you're given from your formula sheet. The brake power that is given to 2 pi Tn over 60, which is the torque in this case. This is T for torque and this is N for speed in revs per minute. The 60 is to convert to the speed in revs per second. So if you are to check the N, we have the speed in revs per minute. We're given the speed, remember? We had the speed. Were we given the speed? Yes, we're given the speed, remember? It was 2,400, the speed we were given, 2,400. But we do not have the torque, and the torque is equal to the force times the radius. And we are not having any force, we are not having any radius. So this formula is limited. Let's move on to the second formula. The brake power is equivalent to this, which is P brake mean times ln. We have got this P brake mean. we are given this. So this is the best formula to use. Okay, let me write that formula. That is the best formula for us to use. It states that, okay, let us see our formula here. So we said it states that the second one, we saw that is the one that we can use. That is P break mean, and of which we have got this. That is P break mean, This is mean. All right. So it's supposed to be plan. Some they use plus. All right. Some they use plus. But in this case, I'm just going to use plan. As for me, guys, I'm just going to use what is on the formula sheet, which is plan. It's just one and the same thing as plus, as long as you understand what this part indicates and what does it mean. All right. So in this case, guys, are you going to need this? If we need this, then we will just have, or let me just shorten this. Let me just write it here so that we do not have confusion. This was our indicated thermal efficiency. Still remember this one, no problem. All right. So what are we saying here? That is P break mean. P break mean. We have that. The break mean that was given, the break mean effective pressure. Remember 307. So we have this value. All right, let me explain the other part here. We have got this. Then this is our stroke length. Then this is the area. And then we are given a bore, which is the diameter. So the area is going to be pi d squared over 4. The n from the speed that we are given, that condition of the n, I explained that the n, because it was given as we have got what? We have got 2-stroke. And n is going to be given as what for a 2-stroke? 2,400, which is the revs per second, over 60. 2,400 over 60 times 1. That is to have the revs per second concept. But this one is for the what? The 2 strokes that we are using. All right. So that means we've got N there, and E representing what? How many cylinders are we having? The number of cylinders. So there we have the number of what? Of cylinders. How many cylinders were we given there? We are given 4. So everything is there. It's just a manipulation into the formula. So that is it, guys. Our brake power is gonna be the brake mean effective pressure. That is 370 kilopascal. So this is given in kilopascal. This is given in kilopascal, so that our answer is going to be in kilojoules, in kilowatts, which is kilojoules per second. So this is 370 times the stroke length. L is the stroke length. And we have got our stroke length from our information. Remember, our stroke length per cylinder, it's 0.08 in meters. So the stroke length, as we said in our N5, this is measured in what? In meters. So that's 0.09 times the area. As I said, the area, since we are given the bore, the diameter, it will be pi d squared over 4. That will be pi times the diameter squared. Remember, the diameter, it was 0.08. So that will be in meters over 4. Then times n, like I said, our n, because we are given 2 strokes in this case, is going to be revs per second over 1. So it's just going to be 2,400 over what? Over 60. All right. So that was going to be 2,400 over 60 times 1. Okay. Times the E, which is the number of cylinders that you're given there. Remember, you're given as 4. And we listed this from our information that E is equivalent to 4, a 4-cylinder. So that's it. We've got your brake power. So it's not always that you're going to use the 2 pi nt over 60. No. Sometimes we can use this when you're given the brake mean effective pressure. So that means our brake power was going to give us something like 26,78114, something like that. So it's going to be 1144. So that is going to be 781 kilowatt. So that is our brake power in that case to 3 decimal places. So like I said, sometimes you can take that one from the brake indicated. Maybe we've got the brake thermal efficiency. All right, we've got the brake thermal efficiency, but in this case we do not have. So, and they actually are asking us to calculate that. Take note here, calculate the brake thermal efficiency. Now they want you to calculate that. So you see now, but if you were given, you're going to use it. So because we have the brake power, we can calculate the brake thermal efficiency. I think I showed you guys the formula. Okay, let me just show you again. For the brake thermal efficiency, these are the formulas that we are given here for the efficiencies, okay? I think, all right, where are those efficiencies? On the next page. All right, no problem here. On our efficiencies, here on our efficiencies. All right, so we need the efficiencies here, different thermal efficiencies. So we have got the brake thermal efficiency, which is this one. All right, so everything is there. We calculated the brake power. The mass of fuel per second is there. The calorific value is also there. So we're just going to insert our values into the formula. In this case, we just have to write our formula properly so that we can insert our values. So that's 5.5. So that is our brake thermal efficiency. Brake thermal efficiency is given as the brake power over the mass of fuel per second. Whenever I use this, I talked about this also in another class. I think we were working with it was supposed to be steam generation, and there was a question that needed us to involve the mass of fuel per second, and there was given the brake thermal efficiency. It is the same thing. This is the brake power, which is in kilowatts, simply talking about the kilojoules per second, which is representing what? The kilowatt. The calorific value in kilojoules per watt per kilogram. And this is the mass of fuel, which is measured in kilograms per second. So that gives us our brake thermal efficiency. So that's our brake thermal efficiency is simply going to be brake power. We already have this. So that was simply inserting our values. Our value there, that is 26,781 kilowatts over the mass of fuel per second. Take note, the mass of fuel per second, that is, guys, you're given the formula. Don't fight with the formula. All right. So I talked about also this previously, about this mass of fuel. Remember here, it was kilograms per second. When you converted, it gave us what? 9,2 over 3,600. So this one is just a repetition. 9,2 over 3,600. So that's 9,2 over 3,600 times the calorific value. Remember, we are given this direct, guys, as it is. It was 44,000. Let us not waste much time here. We have already given this as it is. So times 100%, we have got the efficiency. So our brake thermal efficiency is going to give us something like 23,8173 decimal places. That is as a percentage. As a percentage. Just like that. It's a play around of formulas. We are playing with our formulas. That's power machines from N5. Nothing has changed. All right, 5.6. Now I don't know. I think there's a lot of information now. I don't know what to erase, what not to erase, because I might need something. All right, let's just hope we're not gonna need this. But if you need this, let's just hope you're gonna remember, guys. All right, let's just hope you will remember, because I'm just gonna use this part. All right, there we need to calculate the indicated power in kilowatt. That's 5.6, the indicated power. So we have got a lot of things that we can consider for the indicated power. One, there's this formula, the one that we are supposed to use for the indicated power, and I'll tell you why not. Are we not supposed? Why can't we not use this, or why are we supposed to use this formula? Let's check what is appropriate. We remember we need the indicated power. And in the last case, we couldn't manage to use this because we're not having. So we can calculate the indicated power from this because we have got the indicated thermal efficiency, the mass of fuel per second we have, the calorific value we have. So we can use this formula. All right. What about this formula? Someone is asking, why can't we use the normal formula for calculating what? The indicated power, which is this one, which is given as, this is our formula here. It is given as, the indicated power is given as P indicated mean times ln, which is from the plan. So we do not have the P indicated mean. That one that we are given, it was for the brake mean. It was the pre-brake, not for the indicated mean, not for the indicated mean. Do not confuse between the two. That one was for the brake, not for the mean. So mean to say this formula is limited because of this indicated mean pressure. So meaning to say the best formula that we're going to manipulate is the one for the indicated thermal efficiency, this one. The indicated thermal efficiency, because we have this. All right, let us get back them. Let us get back. So that is power machines, guys, for you. Indicated thermal efficiency, remember that was here, this one. The indicated thermal efficiency, remember we calculated here before. So we are saying we can manipulate that. The indicated thermal efficiency is equal to the indicated power over the mass of fuel per second times what? The calorific value. Where we need this, the indicated power. So we can calculate this. This is the same as over 1. All right. So it's simply going to cross multiply. That's 1 times IP. So the indicated power is going to be the indicated thermal efficiency, which is the indicated thermal efficiency. We're going to have it as a decimal to remove the percentage. So that's 0.29746 times the mass of fuel per second. Remember, I talked about this, the mass of fuel per second. I even talked about it somewhere. Now I removed it, guys, but I still remember we said you're going to divide this one. Mass of fuel per second, we said it's going to be 9,2 over what? 3,600. We changed this. So it does not change. It's still the same. 9,2 over 3,600 times what else do we have? Here we've got, all right, we're going to remember you're cross multiplying. So this is 1. The indicated thermal efficiency times the mass of fuel per second times what? The calorific value. We also have the calorific value. Remember, that was 44,000. Remember, I said this when using it, it is in kilojoules per what? Kilojoules per kilogram. Take note, guys. In kilojoules per kilogram. Take note. So mostly they give you in megajoules per kilogram. You have to change that. So that's our indicated power in this case. All right, so that is everything that we just needed. And that was going to give us something like 33,000. That is 33,448 kilowatts. All right, that is giving our answer in what? In kilowatt. That is the idea there. Let's move on. 5.6 again. So my guys, the information, there's too much information here. The mechanical efficiency, 5.2. We have the brake power. We now have the indicated power. So you can calculate the mechanical efficiency. What is the formula? There's a formula there. Let me show you again. Maybe you might say, where's the formula from the formula sheet? I want to properly see where the formula is. There is a formula for the efficiencies. Where are those efficiencies? For this one, for the one that has got the brake power, this one. The mechanical efficiency is equal to the brake power over the indicated power. So we simply need those two. That's it. Brake power, indicated power, and we have the two. We have the brake power, we have the indicated power. So let's see. So that is it here. 5 point, that is 5 point what now? Okay, guys, very sorry for that. Like I said, there's now too much information. All right, that is 5.7. Okay, 5.7. So I'm just gonna erase one of these guys. We have got these values, so just gonna erase. I'm just gonna remove this part. All right, so that is our mechanical efficiency as we saw from the formula, from our formula sheet. That is the brake power over the indicated power. So you're gonna use the brake power over the indicated power, then you're just gonna multiply by 100%. So we have got everything here with the brake power. We calculated this before. This was our brake power, which was 26,781 in kilowatts. All right, so we've got our brake power here, and also the indicated power. We are also given, where is it here? We calculated, remember, we calculated the indicated power. We got 33,448. So that was going to be 33,448 8, then you multiply by 100%. That was the indicated power. We have got everything. We calculated this. So that was going to give us the mechanical efficiency in this case. All right. Everything was there. So that was going to be 80,06756. So that will be 768% because it was 756 and so on. So that was changing to 8. Okay. That is it. Then the last question was to calculate the specific fuel consumption. That is the specific fuel consumption. This is the brake specific fuel consumption, all right? The brake specific fuel consumption. That is the one that is measured in kilograms per kilowatt hour. And we have this from our formula sheet. All right, let's just, I'm just gonna take you back to your formula sheet, guys. I want you to be very, very much related with your formula sheet because that is the only friend that you're going to have in the final exam, as no one is gonna be there. This will be your only friend. So this is the formula that you're going to take for the brake specific fuel consumption. So just gonna take this, the brake specific fuel consumption in kilograms per kilowatt hour. So this is what you're gonna take. Remember, it's mass of fuel per hour. Mass of fuel per hour, as it is the mass of fuel per hour this time, not per minute, not per second, as it is given in kilograms per kilowatt hour. Per kilowatt hour. Okay. Let me take it this way. Here. All right. I'm just gonna hope we're gonna win here. Like I said, guys, I'm just gonna remove some other things. Okay. Or let me write it aside here. Let me just write it aside here. So you see N6, guys, there's a lot of things to consider. We have few videos, guys. It's because of this. There's a lot of things that we need to consider, guys. A lot of things. Anyways, like I said, 5.8, the specific fuel consumption, which is the basic specific, the brake specific fuel consumption. That is F here, sorry for that. That is FC. All right, that is the brake specific fuel consumption. Okay, so this is given by the formula, as we are given from our formula sheet, as we saw, guys, that this is going to be given as the mass of fuel per hour. This is what they want, over what? The brake power, as it is. This is what they are going to need from you. So you take your mass of fuel per hour. So there's nothing that you're changing this time. The mass of fuel per hour, as it was, remember, it was given as the mass of fuel per hour, the one that we're converting to write in kilogram per second. This, it was given as 9.2 kilograms per hour, as it is. Nothing, there's nothing that you're changing there. So it's 9.2 kilograms per hour. All right. So this is 9.2 kilograms per hour over the brake power. All right. We calculated our brake power, guys, and we also considered this our brake power. This was our brake power here, which is 26.781. This is a value that we calculated before. So that is it. So we can consider this as, if we divide, that was going to give us 0.343527, which is going to be 344 to 3 decimal places. All right. So it's a fuel consumption, which is measured in kilograms per kilowatt hour. Per kilowatt hour. That is how the questions are given. So like I said, we just need to work with more questions, more different typical questions, so that you'll be able to understand how do they ask questions on your internal combustion engines. But these and some other of these formulas, 90% of these, you're going to repeat them in another question. So if you take seriously all these formulas that we mentioned and how do we use the units there, you see that you can answer at least 60% of any other question that you see that needs you to apply as long you're dealing with what? An internal combustion engine. Now you've got 60% from there that you can consider to answer any question. So consider your formulas and consider the units of each formula, how it is affected. And I tried by all means to show you guys how do you apply your units. So we shall see more questions to come from Meds on African motives till we meet again.